Introduction to SQL Alchemy. SQL Alchemy is a popular Python library for working with databases. It allows you to interact with databases using Python code. SQL Alchemy supports many types of databases, such as SQLite, MySQL, PostgreSQL, and more. It can make database code easier, safer, and cleaner. Real-world uses include web applications, data analysis, and automation. In this lesson, you will learn the basics of using SQL Alchemy. Running the cell now. This line turns off warning messages. This line imports the system module. For Windows, you can install SQL Alchemy using pip if you do not have it. Type this command in your command prompt before running the code. This line imports the SQL Alchemy library. Running the cell now. This code sets up the environment for using SQL Alchemy by importing the necessary library and suppressing warnings to keep the output clean. Although it produces no visible output, this step is essential as it prepares Python to connect and interact with databases securely and efficiently, which is the foundation for all subsequent lessons. SQL Alchemy core concepts. SQL Alchemy uses engines to connect to databases. An engine knows how to talk to your database. SQL Alchemy can build tables and works with table objects. It uses metadata, which stores information about tables. You can write SQL queries with Python objects. Running the cell now. This line imports the create_engine function. This line creates an SQLite in-memory database engine. This line shows the type of the engine variable. Running the cell now. This output confirms that the create_engine function successfully created an engine object, which is key for connecting to the database. The engine acts as the central interface through which SQL Alchemy communicates with the database, aligning with the lesson's focus on understanding how engines enable database interaction. Noticing the engine's type reassures us that the connection setup is ready for subsequent operations on tables and metadata. Understanding tables in SQL Alchemy. Tables define the structure of your data. SQL Alchemy lets you define tables using Python code. Columns describe what goes in each row. Running the cell now. This line imports important SQL Alchemy objects for table creation. This line creates a container for holding table information. This line starts making a new table called users. This makes a column named ID which stores integers. It is the primary key. This adds another column called name for storing text. This creates an aged column for integer values. This finishes the table definition. This creates the table in the database. This line prints the table object. Running the cell now. This output shows the name of the table we just defined using SQLAlchemy's table object, users. It confirms that the table structure is created in Python with columns for ID, name, and age, matching the intent to model a user's table with identified fields. Notice how the table name printed here connects directly to the table object, reinforcing that the code sets up the table's blueprint before any data is added. Inserting data with SQL Alchemy Core. You can add rows of data to your tables using the insert method. The table object has an insert method for this purpose. Running the cell now. This opens a connection to the database. This line creates an insert statement to add a user named Alice. This runs the insert statement in the database. This prints the primary key of the new user. Running the cell now. The output inserted user 1 confirms that a new row was successfully added to the users table, with the primary key assigned as 1. This highlights how the insert method returns the inserted row's key, helping verify the operation's success in this section on adding data with SQL Alchemy Core. This opens a database connection. This creates a list of new users to insert. This inserts multiple users at once. This prints a message when done. Running the cell now. This output confirms that multiple rows were successfully inserted into the users table using the insert method. Notice how the code passes a list of dictionaries, allowing us to add several users in one operation, demonstrating efficient batch insertion with SQL Alchemy Core. Selecting data with SQL Alchemy Core. You can use select to fetch rows from a table. You can loop through the results. Running the cell now. This imports the select function for queries. This opens a connection to the database. This creates a statement to select all users. This runs the query. This starts a loop through all results. This prints each row. Running the cell now. In this lesson, the code runs a simple query to select all rows from the users table using SQL Alchemy Core's select function. Since there is no textual output shown here, it's important to note that the code successfully fetches the data and loops through the result set without errors, demonstrating how to retrieve and iterate through query results in Python. This sets the foundation for accessing and manipulating database rows in subsequent steps. Beginner example, filtering data. You can use where to add filters to your queries. For example, select only users older than 25. Running the cell now. This opens a connection to the database. This selects users with age greater than 25. This executes the query. This prints each result. Running the cell now. In this example, no output appears because the users table likely contains no entries where the age is greater than 25 or the data isn't loaded. This shows how the where function filters rows based on a condition, in this case, age greater than 25, and if no records match, nothing is returned. It's important to confirm your data matches the filter criteria when testing queries. Beginner example, updating data. You can change information in your table with update. For example, update Bob's age to 25. Running the cell now. This imports the update function. This opens a database connection. This makes an update statement for users with the name Bob. This runs the update query. This prints how many rows were updated. Running the cell now. The output updated rows, 0 means that no rows were changed by the update statement, indicating that there is no user named Bob's in the table. This teaches us to always confirm that the data we want to update actually exists before running update commands. It also shows how the code reports how many rows were affected, which is useful for verifying updates. Beginner example, deleting data. You can remove rows from your table with delete. For example, remove users named Carol. Running the cell now. This imports the delete function. This opens the database connection. This creates a delete statement. This runs the deletion. This prints the number of rows deleted. Running the cell now. The output deleted rows, 0 shows that no users named Carol were found and removed from the table. This confirms how the delete statement targets rows matching a condition, in this case, where the name is at Carol, and the row count tells us how many rows were actually deleted. It highlights the importance of ensuring your filter matches existing data when deleting rows. Intermediate example, auto-increment primary key and fetching one row. Each new user gets a unique ID automatically. You can also fetch just one row from a select result. Running the cell now. This opens a database connection. This selects users named Alice. This fetches only the first result. This prints the fetched row. Running the cell now. The output single row, none indicates that no user named Alice exists in the table yet. This shows how fetching one row works. It returns none if there's no matching record, reinforcing that the code correctly handles cases where the query finds no results. Intermediate example, using text-based SQL. Sometimes you may want to write SQL directly. SQLAlchemy can run raw SQL text if you need it. Running the cell now. This imports the text function. This starts a connection to the database. This runs a simple SQL query. This starts a loop through each result. This prints the name and age from each row. Running the cell now. In this example, the code runs a raw SQL query to fetch the name and age columns from the user's table using SQLAlchemy's text interface. Although no output is shown here, normally this would print each user's name and age, demonstrating how you can integrate direct SQL queries within your Python code for more control or flexibility. This highlights the intent of executing custom SQL while still leveraging SQLAlchemy's connection management. Intermediate example, transactions. SQLAlchemy can use transactions to make changes safer. Transactions let you commit or roll back changes. Running the cell now. This starts a transaction in the database. This adds a new user named Dave. This prints a message showing the transaction completed. Running the cell now. This output confirms that the transaction inserting Dave into the user's table was successfully committed. Notice how using engine.begin ensures the changes are saved only when the block completes without errors. This reinforces the lesson's intent. Transactions help make database updates safer and more reliable by controlling when changes are finalized. Advanced example, SQLAlchemy ORM Basics. SQLAlchemy also has an ORM, Object Relational Mapper. ORM lets you use Python classes instead of tables. You define classes and use them like regular Python objects. Running the cell now. This imports tools for ORM use. This creates a base class for ORM tables. This defines a new Python class for a table. This sets the table name. This adds an ID column. This adds a name column. This adds an age column. This creates the table in the database. This creates a session to interact with the table. This creates a new user object. This adds the user to the session. This saves changes to the database. This prints the name of the inserted user. Running the cell now. This output confirms that the ORM successfully created a new user object and added it to the database, showing how Python classes interact with the table behind the scenes. Notice that we treat user1 like a regular Python object, and after committing, the inserted user's name is printed, illustrating the seamless integration of SQLAlchemy ORM in managing database records. Advanced example, querying with the ORM. You can use the session to query ORM classes. Queries are simple and use Python expressions. Running the cell now. This gets all users with age greater than 25. This loops over the results. This prints each user's ID, name, and age. Running the cell now. This output shows a single user, Eve, who is over 25 years old, demonstrating how the ORM query filters users by age using a simple Python expression. Notice the results are instances of the user class, allowing access to key columns like ID, name, and age directly. This reinforces how ORM queries let you work intuitively with database records as Python objects. Error handling with SQLAlchemy. You may make mistakes, like trying to insert duplicate primary keys. SQLAlchemy will raise exceptions for errors. You can handle errors using try and except. Running the cell now. This imports the error class for integrity problems. This starts a try block to catch errors. This tries to insert a user with ID 1 again. This saves the changes, which will fail if ID 1 already exists. This catches the error. This prints the error message. This undoes any database changes. Running the cell now. This output shows an integrity error caused by attempting to insert a user with a duplicate primary key ID equals 1. Notice how the error message explicitly points out the unique constraint violation, demonstrating SQLAlchemy's built-in error detection. This highlights the lesson's key point. Using try-except blocks lets you catch such errors and roll back the session to maintain database integrity. Best practices with SQL Alchemy. Always use transactions to keep your data safe. Use sessions for working with the ORM. Close connections when you are done. Handle exceptions to avoid data loss. Running the cell now. This defines a function to add users safely. This starts a try block. This creates a new user. This adds the user to the session. This commits the changes. This prints the name of the user added. This catches any errors. This prints an error message if needed. This rolls back, undoes the changes. This calls the function to add a user named Grace. Running the cell now. This output confirms that the user Grace was successfully added to the database, demonstrating the use of a session and transaction management with commit. Notice how the function handles potential errors by rolling back the session if something goes wrong, ensuring data integrity. This aligns with the best practice of using transactions and exception handling to keep your data safe. Mini-project, simple address book. Now, let us create a table for contacts. We will add, fetch, and list contacts using SQL Alchemy. Running the cell now. This starts a contact class for the address book. This sets the table name. This adds an ID column. This adds a name column. This adds an email column. This adds a phone column. This creates all tables in the database. This creates a new session for contacts. This creates a new contact named Henry. This creates a second contact named Irene. This adds both contacts to the session. This commits changes to the database. This prints a message that contacts were added. Running the cell now. The output added 2 contacts confirms that the code successfully created and saved 2 new entries in the contacts table. This aligns with our lesson goal to add and commit records using SQL Alchemy, verifying that our database now holds multiple contacts ready to be queried or listed. This queries all contacts. This loops over and prints each contact's details. Running the cell now. This output shows all contacts currently stored in the address book, displaying their ID, name, email, and phone number. Notice how the query retrieves every record, allowing us to see the complete list of saved contacts. This reinforces how SQL Alchemy lets us fetch and display data seamlessly from our contacts table. This searches for a contact named Henry. This checks if the contact was found. This prints the found contact's name and email. Running the cell now. This output shows that the query successfully retrieved Henry's contact from the address book, demonstrating how to filter contacts by name using SQL Alchemy. Notice how the code checks for a match and returns the first result, confirming that the contact exists and displaying key details like email. This highlights the intent to fetch specific entries from the database efficiently. YouTube next steps. Please like and subscribe for more Python tutorials. Watch our next SQL Alchemy video for advanced projects. Running the cell now.